Today's lesson, we're going to continue graphing rational functions, but this time, instead of horizontal asymptotes, we're going to have slant or oblique asymptotes. When you have oblique asymptotes, you do not have horizontal asymptote. So, quick sketch of some possible graphs that you'll see today. So here we have a vertical asymptote and an oblique asymptote. So sometimes we have our function is in between the asymptotes like this. And then sometimes we have our functions are on the outsides here. So these are the most common that you will see today. It's possible you can still have more than one vertical asymptote. So you could have something like this. And then you can still have something going on in the middle. And then it's possible that you have an oblique asymptote and no vertical asymptote. We'll even have a question that does something like this, where it goes up and it crosses it and then comes back. So it has asymptote like on top of the oblique asymptote and one on the bottom. So when do we get these oblique asymptotes? So if you see, we've got rational function, polynomial on the top, polynomial on the bottom. We get an oblique asymptote when the degree on the top is exactly the degree on the bottom plus 1. If the degree up here is 1 higher exactly than the degree on the bottom, that's when we have a slant asymptote. And it's also why we can't have a slant asymptote and a horizontal asymptote at the same time, because when the degree is higher in the numerator than it is in the denominator, there is no horizontal asymptote. So here we have two examples where we are going to calculate that the slant asymptote. And we do that by dividing our functions. So I'm going to do long division for both of these. Okay, so x squared divided by x is x, and now multiply x squared minus 3x, subtract. So we'll get negative 4x and bring down our 10, and then divide again, so we've got minus 4. Multiply negative 4x plus 12, subtract, and then we get this remainder negative 2. Now, the remainder does not matter in finding these asymptotes. What we have as our answer up above, that is our asymptote. We have a diagonal asymptote at the line, the linear line y equals x minus 4. So that's just a linear equation. That's a linear line, and we're going to have something above and below that asymptote. Okay, we're going to do another one, and I know you guys are good at long division, but we're going to do one where we have fractions within long division, and you're not used to seeing that. So the process is still the same. If we do x squared divided by 2x, that is 1/2 x. And then multiply. So I'll have x squared minus 3/2 x, subtract. So that's the same thing as negative 4 plus 1.5, which is negative 2.5 or negative 5/2. So then put in your negative 5/2, bring down your plus 1, and now I have to divide again. So I'm doing negative 5/2 divided by 2, which is negative 5/2 times 1/2. So I've got negative 5/4. Now, if I continue to finish this, that'll just be about getting my remainder. I already have my equation here, so I don't need to continue doing my long division because I have my asymptote. At the linear line, y equals 1/2 x minus 5/4. Okay, so ending the video, now actually putting all that information onto a graph. So first off, let's look for any vertical asymptote. We can see in the denominator, we will have an asymptote at x equals negative 4. Let's put that on the graph. And then to find the oblique asymptote, let's divide. Now, if you want, this one we could do synthetic division. We could put a -4 here, do 1, 3, -3. I think on our assignment we don't get a lot that you can use synthetic division, but that's okay. So -4, -1, +4, 1. This is the remainder. That's not used. So we just are turning this. It's y equals 1x minus 1. So let's graph that. Y-intercept -1 with a slope 1. So now it's just a matter of finding some points so we know like which section of the graph to draw. So just like before, I think it's helpful to find our intercepts and then find points on different sides of like vertical asymptotes. So we could look at -5 and -3. If you plug in 0, we'll get -3/4. Okay, so we know our graph is in between those asymptotes. What happens if we plug in 0, or not plug in 0, but set it equal to 0, the numerator? So for this one, this is not factorable, so you'd have to do the quadratic formula and get an irrational solution. So I'm going to just skip that one and see if we can find some other points that will be helpful. Let's plug in -5. So if you plug in -5, up top we'll have 25, and then -15 minus 3, all over -1, which will give us -7. So let's plot that, -5, -7. And then if we plug in -3, we'll have 9 minus 9 minus 3 over 1. So that'll be -3. So now we have got enough information that we can at least sketch our graph. So there's your full video on graphing rational functions that have oblique asymptotes. Good luck with your lesson.